Okay, we're going to add one other twist to the problem now, and then we have one more twist to add, that'll be our last rotation twist. We're going to find the volume when we rotate one curve, just one curve, around a different axis, when we rotate around a different axis. And in the end, we're going to use the same technique, because everything is still about finding whenever we're rotated, we're always going to have cylinders or washers if we cut pieces out. And our volume of each cylinder is always going to be pi r squared h, where h is going to be our thickness, always. And our r this time is going to be different. In the past, it was always y or x. Well, it's still going to contain a y or an x, but it's also going to have the axis we're wrapping around on there. We're either going to be adding something on or taking it off, because we're going to make our picture either bigger or we're going to make it smaller. The directional stuff is still going to work out the same. And we're going to have two pieces, an upper and a lower. The upper is most likely going to be our curve, and the lower is most likely going to be our axis, depending on what we're doing. No matter what you think about the problem, it's all about that radius, and it's always about finding what the radius, this distance from the center of your graph to the top of your graph, is going to be. Once we find that, we've done the problem. We're either going to wrap something around an axis that's below the x-axis to begin with. So it's going to make a bigger picture than if we wrapped around, oh god, that's horrible. It'll make a bigger picture than it would if we wrapped it around the x-axis. Or we're going to wrap it around a line above there. Why would it make that the same color? I don't know. And it's going to make the picture smaller. So when it's something like this, we're going to subtract. And when it's something like the other one, we're going to add on. I'm going to show you both examples. I'm going to work out the algebra on it, whether it's a calculated problem or not. And the first problem we have to look at is we're going to wrap the curve, y equals x squared plus 3, around the line y equals 5 from x equals 0 to x equals 1. And what that graph will look like is a happy parabola from 0 to 1. And we're going to wrap it around the line y equals negative 5. So we know that line is going to be down here somewhere. I'm not drawing this to scale. You'll have to live with that. That's negative 5. And we're going to, as we wrap this around, you're going to see it's going to go all the way around like this. And because we're wrapping the entire curve around, it's going to give me a shape. Kind of looks like a solid. Well, it's a solid. We know it's going to be solid here. Let's wrap that whole thing around. So the volume we're going to get is going to be bigger than what we wrapped around if we just wrapped around the x-axis. It's going to look like a table with kind of curvy sides in if we were to stand it flat on edge. Well, this curve is y. So we're going to work this problem out just like we worked the others. We just have to be careful. And the key on the problems, and if you notice I've done this step the whole time, is I've always just drawn one slice and the radius. The radius is going to start here, and it's going to go up to here. Now, I'm going to add another step in. We haven't done in the past, but we actually have done it. It's just something you don't see. My radius is always going to be upper minus lower, no matter what that is. In the past, my radius was always 0, so upper minus 0 was just the same as upper. So we're going to work out this problem by starting to set up an integral for that one slice. It's going to be the integral. Put pi on the outside. I'm starting at 0, and I'm ending at 1 because I said to, and I'm going to work out the end first. Which direction am I slicing? Well, the nice thing is, whatever direction this line goes in, it matches an axis, so it matches the x-axis, so we're slicing in the x direction, dx. But now I've got to find my radius. Let me describe what that radius is going to look like, and then I will just show you the easy way to find it. From this distance from here to here is equal to y. We know that. And this distance from here to here is equal to 5. So the actual radius of that piece is going to be y plus 5. But you never, because we added more on by rotating around that other axis, you never have to think about that. It's always just upper minus lower. The upper axis is y, minus the lower axis is minus 5. And that is the correct answer. Oh, it's a minus right there. I'll simplify it in a second. But what you've seen is the same technique we had before. If this says dx, it'll have y on the radius. It just has another piece with it as well. And that's the 2 that's in there. So I'm going to write this equation, 0 to 1 of y plus 5 squared dx. Now in my head that makes sense because I'm adding an extra 5 in the middle. I can't integrate because I need everything in terms of x. So it's going to be pi. The integral from 0 to 1. Let's get it in terms of x. Y is x squared plus 3 plus 5 squared dx. Okay, you have Cole help you. What are you watching, Star Wars 3?
Yeah, but I can't get it back to.
Okay, go ask Cole to help you. He will help you. So just going to simplify that integral. If it's a calculator question, put it in just like that. You don't have to simplify it. And you can see it's going to be pi, the integral from 0 to 1 of x squared plus 8 squared dx. Now that's something I could just put in the calculator as well, but I'm going to work it out algebraically right here. I'm going to go to my next page. Pi, the integral from 0 to 1 of x squared plus 8. Just fix it for him, Cole. Integral, sorry, of x squared plus 8 squared dx. There's a couple ways to take this integral. I could try by using the chain rod look on the inside. The derivative of the inside is 2x. I can't counteract that, so I can't take the integral that way. But if it's squared, I could just work it out to see what it would look like. So it's going to be pi, the integral from 0 to 1. I'm going to square this. Remember, squaring anything is square the first term, x squared, x to the fourth, square the last term, a squared is 64, and the middle term is multiply these two. This is just foiling, it's the fast way. 8 times x squared is 8x squared, and you double that, 16x squared. The rule on that is actually a plus b squared, this is an aside, equals a squared plus 2ab plus b squared. It always works. So back to the problem. Dx. I'm not concerned about getting a number because my limits are 0 and 1, so I should be in pretty good shape. This equals pi, and I'm ready to integrate. So the integral of x to the fourth is x to the 5 over 5, or 1/5 x squared, plus x to the third over 16 over 3, plus 64x from 0 to 1. And the first answer you have to yourself is yes, this is going to work out nice because it's between 0 and 1, so it becomes pi. Let's do the upper minus lower. Let's put in our numbers. 1/5 plus 16 over 3 plus 64 minus all those numbers going to 0, which equals, it's kind of annoying. They wouldn't really give us one that bad, but in order to add these suckers together, I have to get the same base for each one. And it looks like to me the easiest base is going to be 15. I'm going to multiply these by 3. And I get 3 over 15. I'm going to multiply these by 5. Plus 3 times 5 is 3 times 5 is still 15. I don't know what, in my head as I work it out, I don't know what 16 times 5 is, but I could work it out, but I know 16 times 10 is 160. So 16 times 5 has to be half of 160. So it's going to be 80 plus this, I have no clue. I've got to do 64 times 15 off to the side. 20, 6 times 5 is 30, 32, 64, 0, 4, 5, 6, plus 960 over 15 minus 0 equals pi, and in parentheses I've got over 15, I've got 960, and 80 is 1,960, 80 is 104, and 3 is 1043. So the final answer is 1043 over 15 pi, which is an acceptable answer. Once again, this might be a calculator problem, but sometimes it's not. Now, this was one, just to peek back at this, and on this next one, I'm not going to do all the algebra out on it. it's where the curve was below the x-axis. Well, watch what happens when the curve is above the x-axis. We're going to set up almost the same problem. We're going to set up y equals x squared plus 3. And we're going to wrap it around the line y equals 1. And we're going to go from x equals 0 to x equals 0 to x equals 1. So it's going to look the same. It's going to look like this. And we'll put our line 1 in there, which is going to be here. So this time we're wrapping around that line. So what's going to happen is it's going to look like this, which is going to be the same exact shape. It's just going to be smaller than it would have been if I had wrapped it around the x-axis. There's going to be less volume there. And the key again is just draw one slice and mark off what you think the radius is. This curve is y, this curve is 1. I can sit and think about it all I want, but I know that this distance is y, and this distance is 1, and the piece I want is this piece right here, which is going to be, once again without thinking about it, upper minus lower, y minus 1. Don't even think about it. So a slice is pi integral r squared. What direction are we chopping? Chopping in the x direction. Pi r squared dx. Pi, the integral from 0 to 1. Dx. Our radius is upper. Y minus lower. Minus 1. Dx. And that makes sense. I'm taking y and removing some volume, getting rid of some. Squared dx. So now I've got to get rid of the y's, get it in terms of x. I've got pi, the integral from 0 to 1 of y is x squared plus 3 minus 1 squared dx. Non-calculator, put that in just like that. Sorry, calculator, put it in just like that. Non-calculator, you can simplify it. X squared plus 2 squared dx. And now I know I said I wasn't going to work it out, but give me the Kramer dollar. I'll take it now. I'm going to work it out. X plus 2. X squared plus 2 squared dx. First I'm going to multiply it all out. I'm going to use that rule I just did before. It's going to be x to the 4th. 2 squared is 4. 2x, so x squared times 2 is 2x. I need 2 of those, so it's going to be x squared plus 4x plus 4 dx. Just follow the rules for squaring. And now I'm going to integrate. So it's pi. Let's integrate. It's going to be x to the 5th over 5 plus, well, that's a squared, I know that. 4x to the 3rd over 3 plus 4x. But easier numbers, but oh, don't close the parentheses. From 0 to 1. I know I can forget about the 0. It's going to give me 0, so it's pi 1/5 plus 4/3 plus 4. Close parentheses. So I've got a little bit easier of a time here. I'm going to multiply these by 3. And these by 5, and this by 15. So it's going to be 5 over 15 plus 20 over 15 plus 4 15s is 4 15-minute periods, 60. So the answer is going to be 60, 70, 85 over 15 pi. You're not required to simplify. If you wanted to, 5 goes into this. 17 over 3 pi. Only simplify if you have to. You notice the volume of this one is significant. Well, look at it this way first. It's 85 over 15 pi. The volume of that one is significantly lower than this one was, which was 1043 over 15 pi. So in the next video we'll try it in the y direction, but the same thing. Always, always, always your radius. Your radius is going to be equal to upper minus lower.